Well, thank you for the opportunity, and it's a great pleasure to be here. As the old saying goes, history according to the historian, and there are at least 28 of them here in this room, many thousands more out there, and that is a tribute to the success of the enterprise over the past 3 decades of creating such a community, and clearly AGCI has been in the forefront of community building. That's a message that I would like to maintain throughout the course of my presentation, and the education capacity development. Education in a broader sense, not educating those who do not know about the science of climate, but getting us to come to the same level of understanding about the science, about the terminology, as Jerry was articulating, getting stories straight among ourselves before we could communicate it to others. I've taken the opposite approach as compared to Jeff's, and I would like to reflect on 3 decades of what I believe is a remarkable accomplishment, because we built something that is going to be legacy contributions. Of course, the challenge is, can we maintain it, and can we build upon it? Of course, that's an exciting opportunity ahead, but build a little bit of my personal science contribution throughout that presentation to share with you how my ability as a scientist was enhanced by the capabilities that was brought together through this enterprise. And of course, say a few words about the road ahead if I get a chance. I probably have too much to say. This is really the crux of what has been accomplished. Now being able to talk about, frame the questions in the context of the Earth system, which we were not able to do, and having the tools to go do the experiments that we need to do to understand the complex interactions among the different components of the system as a whole, albeit we are still lagging in terms of putting the humans into the system or the role that they play, although we have made significant progress on that front as well. Of course, we all are recognizing that equally important nowadays is access to the knowledge that we generate. What happened over the first 3 decades is this topic of community building. We had a wide array of disciplines called ecology, hydrology, biogeochemistry, or sort of freshwater ecology, that we had to bring together and transform the thinking to go from very small scale to regional and global scale. And that by itself was a feat. And again, organizations such as AGCI did a tremendous job of helping us building those communities. We recognize that we're going to be swamped by a deluge of observation and information, and we need to be better worried about how to gather, quality check, and maintain those, because we need them over multiples of decades. And of course, the thinking about the Earth system, as previous speakers have talked about, evolved from specific components of the Earth system to the holistic Earth system. And building communities, building institutions, the capabilities to do that is something that we really all need to be proud of. But one legacy contribution that will be there for decades and centuries to come is this community that we have built, because again, most of us come from disciplinary background, been converted to think interdisciplinary, but the new generation that, again, AGCI and other organizations helped bring together are the ones who are going to lead it into the future. So when I started fresh out of university in the sort of early 80s, this is the level of my thinking about the science that we could do. We had built some capabilities to go from here to there. But in the first decade, we used this framework of thinking to transform the science, the thinking, bring the communities together to go from what their backyard type science to regional and ultimately paving the way to global. And the way that we thought we could do that by having a series of such experiments, interdisciplinary experiments all over the world in different biomes, in different ecosystems, climate regimes, in order to be able to understand each component of the system before we could connect them together. So my first sort of introduction to my science was in the early days, trying to make sense of all these measurements that we had from remote sensing. What does it mean in terms of the fundamental first principles related to biology, biogeochemistry, and the behavior of the terrestrial ecosystems? And this did some work that highlighted that we can really decipher some physiological, phenological attributes of the terrestrial ecosystem from these measurements. And notable among them was these photosynthetically active radiation that drives the photosynthesis. And then, of course, being able to distinguish the relationship between that phenomena in the water energy limited or water limited ecosystems or biomes. And that work led to some contribution with late Dave Keeling and others that for the first time we could detect this signal of the greening up or the response of the high latitude energy limited ecosystems to enhanced warming and CO2, and we could quantify this based on a very crude set of measurements that we had that were really not intended for this type of quantitative analyses. The advancing of the ecosystems by as much as about a week, although later on when we did the detailed analysis it was more like 10 days. That was sort of, again, the transformation of my own research going from field scale, plot scale science to the global science, and was truly enabled by remote sensing and space-based observations. The second decade came along in full force because the first decade had gone, the most of the thinking in the first decade had gone into developing the science, scientific questions, and then the agencies, the federal agencies in the US and elsewhere, used those justifications that the science community put together to promote their own, develop their own science programs and promote it. And notable among all of those planning activities at the US Global Change Research Program, which was a consortium of 13 agencies that agreed to come together to share the same set of priorities and science activities at the national level, which was truly remarkable, as some stated Bob Correll played a major role. And then education was an integral part of everything that we planned and we did, because we knew that we needed the next generation of leaders to help lead this enterprise. But what's remarkable, this collegiality among the federal agencies, that they took the science and they looked at their capabilities and their mandate, and each of them came up with a theme or an area where they thought they can contribute to that complemented the other agencies. And that sharing of sharing that perspective and sharing the common priorities and objectives was really the hallmark of USGCRP in the first 2 decades. To the point that when an agency like DOE didn't have the funding to put the energy into the ARM program, another agency like NASA or NSF would step forward and say, well, we'll fund that effort this year, and then you fund the other activities the following year. So that kind of camaraderie support enabled to make the progress. I hope that spirit still exists within the federal establishment today. And then internationalizing that science, building similar networks and capabilities, not only at the national level, at the international level, was key to our success. And there, again, US played a huge role in that context. So this is sort of the period that I was working at NASA. Within NASA, we believe the major transformation that came about is to convince the engineers, about 80%, 90% of the agencies really populated by engineers, to think about the science first, formulate the driver for developing these missions along the lines of Earth system science. And the only way we could convince them by sort of breaking the Earth system into components and aligning them with the program elements that existed within the agencies, including the Sun-Earth connection that Rick was talking about. And this was the framework for thinking within NASA and program planning. And then modeling capabilities that I will speak to later on was the integrating factor to put the pieces of the puzzle together to make the whole sense of the whole. And then this also transformed thinking about the planning and program development within NASA and other agencies, is that we really need to bring the pieces of, for example, the observation system together in a way that integrates those capabilities, and the whole will be greater than sum of the parts. And from the beginning, we thought about how to convert the zeros and ones to useful information that can inform decisions across the lines of the use, but how we make the sort of go from this end of the spectrum to the other end of the spectrum was the center of many, many deliberations and discussions. But this provided the framework for capturing the interest of engineering, technology, computer science, information technology, and communication experts into the programs. I said that the discussion on the modeling framework was also an interesting one, which we had strong emphasis on different parts of the system, but not a framework to put it all together. Here's NSF played a huge role, taking the lead on behalf of all the federal establishment to nurture this Earth system modeling framework that had three components: model development, software engineering to be able to run these complex models on highly complex and parallel systems, and the computational capabilities. And each agency was supposed to provide contribution to enable those set of functions. So fast forward, we get to the third decade, that we had most of these capabilities in place, and sort of everything was peaking, and naturally the scientific community was enjoying this remarkable progress and promoting their science. But one thing that we all forgot to think about, to include our communication strategy and planning for the following decades. And so hindsight 2020, this emerged toward the sort of the middle of the third decade that we started to think about the future, and of course at the national level was a bit too late. And the other observation that I have to offer, that during this decade, pretty much the investments at the US level stayed flat, while the investment globally started to continue to grow. So again, taking a look at this retrospectively, clearly the type of science that I was interested in doing became a mainstream. These type of products are routinely produced during that decade. We could look at the variability in change at the seasonal, interannual, and multi-decadal level based on the observations of the system. And these analyses became even more refined and quantitative, to the point that we were interested in looking at the carbon cycle, different components of it, and being able to quantify that, which really helped advance our science significantly at the global level. And it was a remarkable 3 decades of technology breakthroughs as well. We were fortunate because we were at the we were at the confluence of 3 major technological innovations: geospatial information, telecommunication, computational sciences, that enable us to think very creatively about how to put constellation of the systems together with this surface networks to look at complex interactions of aerosol clouds and radiation. None of these would have been we would not have been able to do any of these things without really the technological innovations. And the thinking about going from data to information and knowledge was there all along. What we didn't know how to bring the experts together to really make this transition from this side of the equation to that side, but more importantly have the sufficient insight into the whole process to make the ultimate product useful to those who want to use it effectively. As I said, education and training was an integral part of everything that we did, both at the national and international level, and community building in the broadest sense to maintain what we had what we had initiated was an integral part of our thinking. So I think I have exhausted my 15 minutes, therefore I won't be able to talk about what I think we need to do for the future, but will be plenty of opportunity to discuss this during the rest of the week. So,
how about if I ask you a question? What do you think we need to do? Our 5 minutes as we transition.
Next decade. This was my next slide. That, you know, I really believe with every single one of the challenges that my colleagues have spoken to and identified, whether being maintaining what we have built well into the next decade or bringing in new insight to the science, we should consider it as a challenge. Building such a complex system was not easy to begin with. You know, we had to go through a great deal of difficulties at the time, different from what we have today. But I consider that to be an opportunity for us. So what I had prepared to share with you is a set of what lessons we learned as a result of the work that we did over the past 3 decades. And then the next companion slide, a few thoughts about what we can do in terms of shaping the agenda for the future. You know, first and foremost, this was the efforts that AGCI did in terms of bringing people together, building the necessary alliances to think about these very complex problems was key to our success. Taking full advantage of everything that existed, we really relied on professional societies to a large extent to mobilize the talent that existed at the national and international level to get the science done. So it wasn't an institute, an organization, an agency. It was truly a national effort, at least, you know, from where I saw it and seen. There was, as I said, there was this sense of camaraderie and cooperation to develop common priorities at the national, international level and share those and support those. And building it, every step of the way, the community was involved in it. And they took the ownership of it. It didn't, you know, it was edict coming down from the top level of the governments or agencies. You know, as I said, we naturally, hindsight 2020, we focused on getting the science done right, and we missed the opportunity on thinking about communication and thinking about the next decades of plans and priorities, and we came to that late, and it was really hard to sell both maintaining what we had plus adding new capabilities to it. Hopefully we have learned a lesson in that regard, and we will think proactively for the coming to the coming decades. And then, you know, we need to sort of come to some level of agreements. What are the most compelling scientific issues that attract the community so that they see themselves in it, and then convince the supporting organizations to fund it. But think about, you know, reaching out to some organizations beyond the traditional source of funding. And clearly, I hope Ian has something to share with us. You know, how can we capture the interest and imagination of the development organizations, communities? They have tremendous interest in what we do, what we plan to do, and hopefully they're willing to invest in it. But we need to think beyond what the traditional communities and boundaries and organizations that we've been working with as we think about the future. Right. All right?
Thank you, Ghassem. So we have time for a second clarifying question as Don comes up.
I don't think yours was a really clarifying one, but
You have to give me a little leeway. This is my boss.
there you go. Let's see. Great. Brown nose.
It was very abundantly clear what I had to say.
Yes,
There
well,
is
we're-
structure.
So Ghassem, the list is very, inspirational and forward-looking. Whenever we build networks, the problem with them has always been sustaining them for the long term.
Yeah.
But I didn't see that which you've done, right? The effort to sustain these activities is not a trivial one. By
Yeah.
simply identifying what the risk is not, that doesn't sustain our capabilities, right? So given the present environment, what's the likelihood of sustaining?
Well, again, we had a purpose for all of this,
Right.
which was very well articulated.
Yeah, definitely.
So that purpose cannot be sustained to be the sole source of justification for maintaining what we have built and building the next one, right? So that's the task ahead. Define that purpose that we know that we have to do the science in order to build a solid foundation for what we have to deliver. But the opportunity for making the knowledge that we generate for those who could use it is at least one possible venue to do it, to promote that. But how do we organize ourselves to do that? And how do we bring in those who have a vested interest into the process? I don't think the science community is quite ready to do that, but I think the time is here for us to really take that journey.